Hello everyone. So in this video, I want to cover function calling, tool calling, structured response, JSON mode, whatever you want to call it, right? And this is very important because we are in the journey, in the process of learning agentic flows, and we are learning a very special framework called LangGraph. And we saw how LangGraph helps us in reducing the hallucinations in large language models, right? So one of the ways to do that is to have the agent very clearly know what the end condition is, right? So we define the conditions, the flow conditions within an agent. An agent very clearly knows when to do what. Instead of hallucinating and believing that the agent is done, it will actually follow a very structured approach. There are many other ways in which hallucinations are being dealt, and LangGraph has this very clear and promising way of defining the flows. And I will actually show you in this fifth example over here, which is where we are, slowly building up to see how we can mitigate hallucinations as much as possible. But before we can do that, we need to understand what function calling is, what tool calling is, right? So function calling is in a way a foundation to development of AI agents, because function calling is a technique that will allow you to interface with external systems. It will allow you to define certain tools, provide those tools to your LLM, and then LLM will be tool aware. You can bind those tools to LLMs. So even though LLM is not capable of originally performing certain activities except for text generation, after you writing your custom tools or custom APIs and providing it to your LLM will be smart enough to do that. So let's take a look at a diagram, right? So let's see a very general flow that you might be developing in your local looks like this. You as a user, you're going to ask a question or you're going to send a prompt request to your Ollama server, which is normally hosted on 11434, right? So the way you would interface with that is you'll have some kind of Python code in between, and you will send this request to your Ollama server, and your Ollama server, which has any large language model in the backend, is going to respond back to you in the form of text generation, right? So that's why it is your GPT. So the response back is just a neural network's generative response, right? So whatever the model was trained on, it will only have the information based on that training data. So it is in a way frozen in time. It does not have awareness of any other tools that are available to the model, right? Because those tools aren't available to the model yet. Those are the custom tools that you're writing today, and the model is kind of frozen in time whenever it was trained. So the training data for these models there is no way that the training data would have known the custom tools that you're going to write in future. So these models, even though they have been trained, some of these models like LLaMA3.1 or some other function calling dedicated models like Mistral 0.3, those models are trained to be, aware of function calling. However, they just do not know which function to call. So the way we enable function calling, or the way we perform function calling, is that we write our own functions, right? So we'll write maybe like 2 or 3 functions over here. So let's say a very common function calling example that you guys will see is get weather, right? So some kind of get weather function. We will also do the same thing. It's very customary to do this. It's like a hello world example, and then get system time maybe, right? So get system time. So what this is that you now wrote 2 different tools, right? So let's say you wrote a tool that can go out and that can retrieve weather for a particular location, right? So this will take an input as maybe city and state, and it will output the weather for that particular location, maybe 65 degrees warm kind of thing. And get system time is another tool that will just use Python library in your local. It will retrieve the system time, and then you will get the information back. If you ask system time to your Ollama server, it has no clue, right? I mean, it does not know what the system time is. It may generate an hallucinated response, but in reality, it would not know what the actual system time is. So for us to tell the large language model that, hey, you do not generate a response if you don't know about it, right? So let's say if I ask, what is the weather like in Woodbury, Minnesota? Will Ollama server backed by a large language model answer it? Of course it will. I mean, it is designed to generate an answer, and it will probably hallucinate. It will say that, hey, the weather in Woodbury is 25 degrees, right? Or maybe it will say, I do not know. I cannot let you know. If it's smart enough model, it may respond back, I do not know what the answer is. I cannot give you a real-time weather information, right? One way or the other, it will generate a response. What it will not generate is the correct response. It will generate a response, not the correct response. So the idea with the function calling or tool calling is to make our large language models aware of these tools that we have, right? So we just want to make sure that whenever the large language models are responding, they are aware of these tools that we are writing. So in the case of function calling, what happens is we send a request to Ollama server asking for, let's say, hey, what's the weather? And Ollama server will use the large language model, and in the context, it will provide that hey, I know about two different functions. I know about a getWeather function whose request and responses look like this. So input parameter and responses look like this. And this is what the getWeather function does. And I also know about another function, getSystemTime. And this is what the input and output looks like. And this is what the getSystemTime method does. And large language model will then make a decision that, hey, the user is asking me about weather, and there is no way possible that I could know about weather, right? So let me just tell the user that if you invoke one of these methods, then you potentially can get the weather data back, right? So when we say that we are performing function calling, what it means is that instead of large language model hallucinating and giving the response back, it will just give you a hint in a very structured way that this is the name of the method that you can call because I'm aware that you have created such a method, right? So this is the name of the function that you can call, and this is how you should use your input parameters of the function, right? So for example, in my getWeather, the inputs are city, state, right? So there is a very structured way in which these parameters have to be passed in this particular method. So the LLM will respond back with the tool name and the arguments. So it will take your natural language and it will respond back with the name of the tool that it needs to call and the arguments that needs to be passed to the tool, right? So my whole sentence was, hey, tell me the weather for Woodbury, Minnesota. It will discard everything else. The response back will look like call getWeather method, arguments, Woodbury, Minnesota, right? So this will now make the task of the Python code that receives the response back very easy. So the large language model does not do the function call. It just tells the code that is getting the response back to do the function call, right? So that is a very key point. Function calling does not mean that the large language model will do the function call. There is no way large language model can do the function call. Large language model will just return a response back that you as a user, you as a code that is executing this call needs to do the function call, right? So once the response is returned back to the Python code, now the Python code will know, okay, yep, I need to call the getWeather function, and that is how I will get the response back for the weather API. And then once the code executes it, then it will send that data back to the user. So in function calling, the flow looks like this. Step number 1, we define which particular tools we want the LLM to be aware of. Step number 2, we bind those tools to the LLM, right? So this is step number 2 over here. We are binding the tools to the LLM, to the large language model. Step number 3, when we are doing the request, right? So when we are passing the initial input, the response that we will get back will have the function calling attribute in it. And we will parse that function calling attribute from our Python code, and we will execute the function, and then we will massage that data back in an appropriate way and send the response back to the user. So this is how end-to-end function calling code will look like. And similar to this, there is another concept called JSON mode and structured output, right? So in JSON mode or structured output, what you can do is, for example, if you have a router, right? So if let's say all you want your large language model is to make a decision based on true or false, right? So let's say you want to pass a certain attribute and a certain request to the large language model, and you want to make sure that the large language model only gives you true or false response. It does not give you a big huge response, right? Big huge text response. And this is where JSON mode is extremely helpful, because or structured output is extremely helpful, because now you can force the large language model. You can tell it that, hey, I only want the response back in this Pydantic, format. So I only want in this particular class format. And now the large language model will obey that. So you can say that, hey, I just only want Boolean back, and it will evaluate whatever your request is, and one way or the other, it has to answer back in that Boolean. So this becomes very useful in many of the agentic flows, and maybe you guys are already thinking where I'm going with this. So in one of our last examples, if you saw that there was a condition, there was a tell joke condition, and this conditional node was true or false in a way, right? Like whether the condition has been met or not. So we can, again, instead of having just a counter to count the number of jokes being told, we could have had another large language model evaluate some special condition and give us the result that, hey, whether you want to go to the tell joke node or whether you want to go to the end node. So if you want to see what I'm talking about, you can refer to the previous video on the LangGraph that I have done, and I'll probably make a playlist and put all of them together in one so it's easier for you to see. But this is what the structured output will look like, and this is why it is very important. Okay, so let's dive into some code and let's just take a look at what I'm talking about. So for function calling, so we talked about that in function calling, we first need some kind of Python code to initiate all those things, and then we have to define these two functions over here. So we are going to use LLaMA3.1 70 billion parameter model, and you need to have like a decent amount of GPU to run this. You can run the 8 billion parameter too, but I just have enough VRAM, so I'd be using this one. And my model is hosted locally in my basement at 11436 port. And you can, this resolves to one of my basement IP addresses. So this is where the model is hosted, and I'm using Ollama functions. Now, this is very interesting. So this was an experimental feature that LangChain had. And let me see if I still have this over here that I can show you. Yep. So Ollama function, this was an experimental wrapper that attempted to bolt on tool calling support to models that do not natively support it. I do not know why they discarded it, So even though they are saying that the primary Ollama integration now supports tool calling and all that, but once you start using the primary Ollama support, there were still other issues that I started facing, that some other models that did support tool calling were saying that they did not. And I haven't found an issue with Ollama functions. Even though they said that it was an experimental module, it just worked like a charm every time, just perfectly for me. So I'm just going to use this Ollama functions. I'll probably make a copy of their Python code and I'll keep it separately over here. I don't want to lose access to Ollama functions. I absolutely love this. And it provides me everything that I would ever need, right? So I would keep this Ollama functions. It gives me the ability to customize the base URL, customize the model, lets me do the JSON format, and it also lets me do tool calling or function calling, right? And that's why Ollama functions it is called. So step one, we define our model, right? We let the Python code know where our model is. Then we define tools. So in this case, get weather API and get system time. So we are also saying that, hey, the input to this tool is string and the output is also string. And similar to that, there is get system time. This is the input and this is the output. So one thing to note over here is that we need to define what this particular method does, right? So the more you have, because this is actually going to be passed to your large language model, this information that, hey, this is exactly what the method does. So let's have it a big clear information over here, and it will randomly, in this case, I'm not actually going out to any particular API. I'm just randomly selecting some weather information and then sending it back based on this. So this is the first tool, and this is the second tool. And again, the second tool is the same thing. I am just sending. Okay, so in system time, it looks like I just copied and pasted this part over here. I'll probably change this before I don't need this part over here. So let me delete that. Oh no, actually that's all right. Retrieving system time randomly. 3 possible outcomes. This fails. All right. Nope. Actually, this is all right. This is all right. I don't need to change anything over here. Okay. So after defining these two tools, the next step is to bind the tools to model, right? So model.bind tools, and because I'm extending from Ollama functions actually instantiating from Ollama functions, it lets me bind the tools to our model, right? So I'm gonna call this model with tools, and I'm able to bind these two, get weather and get system time, to it. And you will see that these are decorated with @tool annotation over here. And this is cool because this is what helps. So this is the magic done by LangChain, and this is what helps us bind the tools to the model. And this is where we are making the model aware of these tools, passing all these extra information and the inputs and outputs of the methods and all that. And this is where the bind tool happens. So if you go back, so these arrows that we're talking about that are binding it to our large language model is this step over here, right? Now this particular section is I don't think this is relevant to our code over here. I'll talk about it in the 4b section, but let's just take a look over here that after binding the tools, what happens. So Once we have bound the tools, let's define a prompt template. So prompt template, now let's take a look at this diagram. So prompt template is this section over here where we are sending a request to the Python code, right? So in our prompt template, we are saying that the system prompt is that you are a smart agent and you are mastered at understanding what customer wants and utilize available tools if you have to, right? So this is not the perfect way of writing system prompt, but this works too. This is the lazy way of doing it, and I will show you the more structured way of doing it in the next example over here. But let's just follow the lazy way. This still works, and then I will show you a more structured way of writing it with tokens. So system prompt says this. User says, hey, conduct a comprehensive analysis of the request provided, and this is the request, initial request, and this will be passed as an input, right? So what we are saying is that, hey, large language model, we have given you some tools. Where are those tools? Those tools are in model with tools section, right? So we will use one way or the other, we will chain our prompt with model with tools to get the final output over here, right? And then when we pass the initial request, our model with tools gets the prompt, and then it generates the adequate response back. All right, so now let's see how this works. So we then create a request generator. So this is again a runnable interface. So what we are doing is we are just chaining. This is the LangChain way of writing. So you create your prompt and you create your model with tools, and then you chain them together over here, and then you have this agent request generator. And in the because agent request generator is also runnable interface now, so we can do invoke on it. And in this invoke, what will be the input parameter? Input parameter will be whatever the prompt is expecting, right? So the prompt is expecting one input over here. And what is that input? Initial request, right? So just one input it is expecting. So we will pass just one input, initial request. What is the weather in Woodbury in Minnesota, right? So you see how I kind of wrote it in a weird way too. And let's see if the code or if the LLM is able to figure out what the final response is. So what I'm doing is after I get this result back, I'm just trying to extract the last AI message, right? So what I'm doing is I'm just checking if it is an instance of AI message, then just get the last AI message over here, and then from the last AI message, first just print it out, then second take the tool name out, and third take the tool calls part of it, arguments part of it out from the tool calls, right? So let's execute it and let's see what it looks like. So Python 04a function calling example. So when we run it for the very first time, it's gonna load the model, right? So there is a 70 billion parameter model that's being loaded, and let's take a look. And I will put this over here. We will see that this model is being loaded in these two GPUs. So my 11436 is the Ollama server for 1 and 3, and the model is still being loaded. And once the model is completely loaded, it is like 21 something. Yep, so it is loaded now, and now you see that now this is processing, right? So now it's spiking up enough, it's processing, and you get the response back. So let's see what's the response. So in our response now, we have the very first, so let me go at the very bottom over here. So we have this is the first print statement, and it says last AI message is literally just that last AI message that we have, right? So this is the last AI message. Content is none, and this is very important, that it did not actually give us any text as response back. It did not say, it did not hallucinate, it did not say anything. It said, nope, there is no content in this AI message. But what there is a tool call section. And in this tool call section, you have to now do this particular tool call is what it is saying, right? So it is not running any tool. It is just giving you that information that you have to do a tool call. And it is saying that the name of the tool is get current weather, and the arguments are this string format, Woodbury, Minnesota, right? So the name of the tool is provided, and the location attribute as argument is provided over here too. So this is very important, because if you see, and I've actually extracted all those out too. So tool name and tool argument. So now you can use your Python code to do exactly this. You can directly just get current weather, and then you can directly just pass this particular attribute to this method, and then you're golden over here. Let me just run this again, and let's see what the response back is. And we get the response back again, the same one. And if I change the initial request a little bit, so let's say in Chicago, and let's say Illinois, and let's see what happens. And you will see that it changed the location this time around to Chicago, Illinois, but the same method for get current weather is being called over here. So this is a very, very good example to show how we bound these two methods to our large language model using Ollama functions from LangChain. And even though two tools were provided, LLM made a determination that, hey, the user is asking me about weather. I am aware of these two tools. Out of these two tools, this is the tool. If I call, then the weather information can be made available to the user. So instead of me hallucinating and providing some random information, let me just return no response back in terms of content, right? So no response was returned back in terms of content, but it did return the tool call section back. And this is huge. So now if you see, the LLM did not call any tool. It was aware of the tool, that a tool exists, but it did not call any tool. It doesn't even know the functional implementation of the tool. All it knows, all the large language model knows, is this section and the attributes, which are inputs and outputs. That's it. It has no clue what's the implementation part of it. So this section it does not know about. So this is very important, because when we do this tool decorator over here, it does not tell the large language model what an actual implementation it is. It just extracts certain attributes, and it sends it to large language model, so it can make a determination whether it has to use that particular tool or not. All right. So now that we have seen a very simple tool calling example, let's actually have the code call the tool too, right? So in our use case, what we did up until now is we asked the large language model a question, we made it aware of tools, it responded back with the particular tool call, in this case get weather tool call, and we stopped over there, right? Now the next very obvious step would be for the large language model to do an actual tool call, right? But it cannot do the tool call, so the Python code will have to do the tool call based on the response that it gets, right? Which is what we will see in this next example. So in this next example, what I've done is cleaned up the code first, right? So it's very customary to not put all your code in the same file over here, but to create a separate tools.py kind of, your module file, and then you can put all your tools separately over here. So it's the same tools, I just cut and paste over here, and that's it. There's nothing fancy going on in this tools.py file, right? Only thing I've done is I've just imported that tools import get current weather and get system time. So from this tools.py, I've imported these two functions over here. So whenever I will do this particular model with tool bind tools, mapping over here, so these will be available because these are being referred to this particular tools.py section. So that is just one small change that you will see. Tool mapping, right? So this is a section that we will utilize when we have to run the actual tool as the response from the large language model. So if you remember in the previous example, I was telling you that this is just a leftover code. So in the previous example, we did not need this actually at all. I can just delete this too, save this file. We did not need that. But in this example, when we are actually going to run this particular tool as a response back from large language model, then we will need to have this particular tool mapping with us. So once the large language model responds back and it says that, hey, it wants to run the get current weather method, then the tool mapping will tell us that, hey, get current weather is actually the function that is defined over here, right? So this is why this tool mapping section is important, and it will be used only when we are going to execute the response back from the large language model. All right, let's go down and see. Everything else is almost the same. This is a little different, right? So you would see that the prompt template that I have written over here looks quite different than the prompt template that was over here. So remember I was talking about how this kind of works. It's okay, but the more appropriate way of defining system, user, and assistant is by using the proper token for that particular large language model. So I am a big fan of LLaMA 3.1 especially, right? It is a game changer. So I would highly recommend that you guys look into it. And if you have to use only one large language model, then use LLaMA 3.1. That's it. As of today, which is July 30th of 2024, there is no better large language model available as compared to LLaMA 3.1. Even the 8 billion parameter model is pretty awesome. So I have the luxury of using the 70 billion parameter, so I'm going to use that. And just make yourself aware of these tokens, like how these tokens are defined. And if you want to know how these tokens are being used, you can go to Ollama library over here, and you can go to your whichever model you're looking for. So like I'm looking at LLaMA 3.1, I can go over here, and then you can see, so not this one. So just a second, I will take a look over here. And it is the, so it's not over here. I was trying to find the model cards, but I do not see the model card over here. So let's see. LLama.meta.com, and maybe it's I'm pretty sure it's in the documentation over here. So let's go to the documentation, models, and LLaMA 3.1 model card right here. Okay, perfect. So you see all these tokens, begin text, end of text, and all that. What all this means has been defined over here. And so I'd recommend just taking a look at this particular link over here. And then I think at the very bottom, they also have different ways in which you can prompt. So this really kind of the instruct version of it over here. And you can see how you can provide a system prompt, and then how you can have, like different kind of user prompts and the assistant over here. So excuse me, this is exactly what I've been doing in our example over here, right? So begin of text, start header ID system, and you are a system, whatever is smart agent and all that, and then exact same thing, but just it follows a more structured approach that helps your large language model understand things very clearly. Okay, so again, doing the same thing. So nothing is special or different up until this point. Then again, we are creating model with tools up there, and then we are chaining it, having the agent request generator over here. And after that, you have your response back from large language model, right? So this is where we are doing an invoke, and we are getting the result. And from that result, we are extracting the last AI message, and we are getting the name of the tool call center. So this is where we left in our last example, right? But in this example, now we will do the tool call. So what we're doing is we are saying that, hey, in this particular result, right? So the result that we got back in this result, take a look at the list of tool calls that you have. And for each tool call, right? For each tool call, go to the tool mapping. This tool mapping is the is what we had defined earlier, which I was talking about, that each name of the method corresponds to the actual method over here. So now we go back. What we are saying is that go to the tool mapping, extract the tool that we have to run, right? So we go to the tool mapping, and from the tool call name, we extract the tool that needs to be run. And then all we have to do is to invoke that tool with the arguments. So now that we are getting the arguments and we are getting the tool name, we can just do an invoke and print the result over here. So let's do that. So in our case, this is Python 04b, and right now, it's probably gonna load the model again because it has been a little while. So it unloaded the model. So let's wait for a few seconds while it loads the model. And I've seen when this number becomes 21 on both of these, then that's when the model is correctly loaded. So these two, so the reason why I chose 1 and 3 for my Ollama server and not like in series is because they were on the same PCI lanes. So 0 and 2 are on 16 PCI lanes, and 1 and 3 are on 8 PCI lanes. So I want to have that consistency for that purpose. All right, so it looks like the model is loaded. And if you see till this point, tool args is over here. This is what the tool args is, and this is what is doing an actual tool call, function call, right? So it went over there in the method over here, and it randomly chose the rainy 60F because that's what this particular business logic is over here, right? So this is what the tool calling end-to-end is. Step 1, you define your tools. Step 2, you bind the tools to your large language model. Step 3, you generate a prompt that is more structured, where you make the large language model that is aware of the tools. You pass that prompt in there, and you tell the large language model based on your system prompt that, hey, make use of the tools if you can. And then the large language model responds back with a tool call in it, and then your Python code extracts the tool call, calls this particular tool, and then sends the response back to the user over here. So this is what end-to-end your function calling or tool calling example looks like. Now we'll build all this in the LangGraph also, but understanding this was very important. The last step that we have over here is structured response, right? So it's very similar. Structured response is very similar to what a function calling is, right? So in structured response, what we are saying is that, hey, format is equal to JSON, right? Similar to what we had earlier in others. So we are saying that, hey, keep your format as JSON output. And we are saying the same thing over here too, that format JSON. And this is the special part of it. So we are defining the Pydantic schema for the structured response. So we are saying that, hey, in this particular one, we are defining a class and the base model over here. We are saying that the one input that we have in this particular class, one of the member variables is result, which is a type Boolean. And the field description for this is either true or false, right? And this is a required attribute, so you must have this particular attribute over here. So what we will do is then we will bind this particular model as the response for the LLM, right? So in previous example, what we have done is we have bound the tools to the LLM, but in this structured response example, we are binding this particular class as an output to the LLM, right? And you will see what this means in a second. So what we are saying next is that if we have a router agent, right? If we have an agent that needs to determine whether whether something is true or false, right? So then we can have the large language model being invoked, and the large language model will make that determination by using its whatever intelligence that the LLM has. So in this case, if you see, I have a system prompt over here, and the system prompt says that you are a smart router agent and you are master at reviewing whether the original question that the customer asked was answered in the tool response, right? So what I'm going to do is this agent actually is something that will take the initial question, right? So let's take a look over here. So let's say if the user had asked the question that, hey, what's the weather in Woodbury, Minnesota? Then we used some tools, we got the tool call response back, then the Python code executed this tool and it got some weather information back, right? So now what this router agent will do is it will take the original question, what is the weather in Woodbury, Minnesota? And it will take the answer from this tool as an evaluation, and it will see that, hey, does the original question and the final answer, do they sound right? So for example, why am I saying this is, if the tool call was get system time in response to what is the weather in Woodbury, and the answer became 2:30 p.m. In that case, when the evaluation will be done, it will fail the evaluation, right? So when the large language model, like if a human is being asked what's the weather in Woodbury and a response you get is 2:30 p.m., you will very clearly say, nope, that doesn't look right, right? So this is where we want to have some kind of evaluation criteria where we can check the final response back before we send it to the user, right? So this is what this is doing, where we will pass in two inputs. One input would be research question and second input would be a tool response. And what we are asking this particular large language model to do is to check whether the initial question or the initial request is being answered by the tool response that we're getting, right? So we'll pass in two different attributes over here, research question and tool response, and all we want to know is true or false whether the initial question was answered or not, right? So to get this true or false, we will bind the Pydantic schema to our structured output. So last time we were doing model and bind tools, and we are binding tools to it. But this time around, we will do model with structured output. And what kind of output we need? We just need an output as true or false inside of the evaluation. So we could have had, like a big set of different attributes over here, and the model would have been forced to do that. But in this case, I just have one single, member variable of this class. So it will just return the response back for that one particular member variable. So now what we are doing is exactly the same thing. We are taking this prompt and we are chaining it with the structured LLM, and we are going to do an invoke, and let's see what the result is. So if the initial question was what is the weather in Woodbury, Minnesota, and the tool response is 65 degrees and sunny, this it looks right? This looks about right. So if we Python 04C. So if we take a look over here now, this probably should pass the criteria. Oh, the model is probably unloaded again, so it's gonna load the model. So let's wait for that. And I probably should put the expiry time. So I don't know if Ollama function provides that attribute, but you can set the expiry time for the models, and you can set it as -1, and it will stay loaded in there forever. But I don't know if Ollama function provides that or not, but either way, we'll get this model loaded in the memory. Yep, it looks like it is loaded now, and it's gonna process. And I think the answer will be true over here. Yep, so the answer is true. And let's run it again. Let's run it several times to see if it continues to say true for this. And the next what we will do is, let's try to put this as 2:30 p.m. right? So this is of course not right. I mean, why would the weather be a time? So let's see what large language model says. It should say false, and yep, it does say false, right? So let's run it several times over here, and we get to know that the response should be, you know, similar to some kind of weather response and not a time response. And we can delegate that responsibility to our large language models evaluation. So these kind of, you know, scenarios will be used in our full agentic flow for the LangGraph. But before we could do the full agentic flow, we definitely needed an understanding of function calling and structured response, right? So in the next video now, what we'll see is we'll have an agent will have some tools available to it. So we'll have the bind tool method to this particular agentic call. Whenever this agent makes a call, it will have the bind tool methods to it. But whenever we have this conditional arrow, so instead of bind tools, we'll have a structured output over here, right? So the structured output will check whether the agent's action, that the action that has been performed, and this action is actual tool execution, right? So whatever the tool execution is performed, does that comply with original agent's request? And if it does, we continue. Well, if it does, we end. If it does not, we continue, and then we keep on going into this flow till the action complies with the original request. All right, so this is it for today's video. I hope you enjoyed it. If you have any questions, or if you'd like to see some more details on any one of these concepts or topics, let me know. And I will see you guys in the next video, where we do the full state managed LangGraph example.